Here's the integrated 3. It's problem CL10-205. It says in a unit circle if cosine, I'll just call that theta, equals 5 over 13, and theta is in between 3 pi over 2 and 2 pi, what are the values of the 5 other trig ratios? So remember we have sine, cosine, tangent. The reciprocals would be like 1 over sine, that's cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. Okay, and so it wants to know what they all are. So there's an easier way and a harder way to do this. I'm going to do it what I think is the easier way. So I made a unit circle, but I decided not to make it actually a unit. Like in a unit circle, here, let me make a tiny unit circle. In a unit circle, we know that the radius is 1. So if this is pi over 2, and this is pi, and this is 3 pi over 2, and this is 2 pi. And that's the y-axis, and here's the x-axis. That's a unit circle, and I'm going to say that it has a radius of 1. Then my angle, which is, or cosine A is 5 over 13, that would be, they said that the angle is in between 3 pi over 2 and 2 pi. So there's 3 pi over 2 and there's 2 pi, so it's in quadrant 4. And they're telling me that cosine is 5/13. So that's not quite 1, right? If it was 1, it'd be here or here. So cosine, remember cosine is the x value. So what is 5/13? It's a little less than half, I guess. So maybe I didn't draw it. So this would be like 5/13 over 1. That could be where cosine is 5/13. I would like to scale up my unit circle and make it bigger so that I don't have to deal with the fractions. So, and maybe this would make sense to you if this is a little triangle. If I multiplied this triangle by 13, well, 13 over 1, like this is opposite, and this is hypotenuse. Or sorry, it's not opposite, it's adjacent. Because cosine is adjacent over hypotenuse. So in a unit circle, the adjacent is the x value, and that, like, it's adjacent to the angle, that's the angle. It's the x value. But I would like to use my SOHCAHTOAs a little easier. So I'm going to multiply the top and bottom by 13 over 1, like it's a giant 1. It's 13 over 13. And that gives me, it makes the 13s cancel out. So, I mean, I don't go through this fraction math. I just look at it and I go, hey, the cosine is 5 over 13. That's adjacent over hypotenuse. So then I can, instead of it really being a unit circle, I've just got a hypotenuse of 13 and I've got a cosine of 5. And why would I prefer that? Well, now I can use Pythagorean theorem. A squared plus, I already figured out, I think this is 12, because I know there's Pythagorean triples of 5, 12, 13, so I didn't have to do the math, but if I wanted to do the math, I could go a squared plus, pretend I didn't know what that was, b squared equals c squared, right? And this is 25 plus b squared equals 169, and subtract, and I would get b squared equals 144, and so b is 12. And why would I do that? Because I need to get all these trig functions. So I know that sine is opposite over a hypotenuse. So sine is going to be 12 over 13, but this is like a negative 12. So it's going to be negative 12 over 13. And then tangent is just opposite over adjacent. So it's just, well, I guess that's negative 12, 5. And then, so I can fill those in, right? I've got negative 12 over 13 is sine. Cosine, we already knew it. It was 5/13. Tangent was negative 12 over 5. Now these ones, for cosecant, we're just going to flip it upside down. And for secant, flip it upside down. And for tangent, flip it upside down, or cotangent. Okay, so cosecant is negative 13 over 12. Secant is 13/5, and cotangent is 5/12. Like that. And let's see if that matches what they got. Yeah, so that's how I do it.